Hello, students. So I just like to round up the chapter on these similar objects, three-dimensional. Um, for task 9 onwards, just to round up the chapter properly, so you can review this over your June holidays. I hope that will be helpful for you, and then we can start afresh on the new chapter which I've just posted on Google Classroom a while ago to prepare ourselves for term 3 and second semester, right? So let's begin. We begin with task 9. So task 9, what we have here is a pair of pyramid, and we are told that they are actually similar. So we want to find the unknown volume. So what we do know, right, is based on the property of similar object. Okay, the volume 1, okay, let me call out my pencil properly. Volume 1 over volume 2 of the second object is actually the ratio of, in this case, we are given the height. So the height of the first object over height of the second object, cube, right? So if we replace this with the values that we do know, right? We are trying to find volume 1 over here, which is the larger object. We can define it as such. Over 48 is equals to 6 over 4 cube, right? Which will result in 27 over 8, right? So V1 is going to be equals to, let's take out my calculator. We have calculator, 27 divided by 8 multiplied by 48. That will give us 162, and the units in this case is cubic centimeter, right? So a simple example. Moving on to the next one, we have two similar cones. This time round, we are given the base diameter, right? The volume of the larger cone is 378, and the mass is 928 gram. So what do we know, right? First of all, okay, the question asks what is the significance of same material, right? Same material implies common density. Therefore, hence, right? Hence, the mass will be directly proportion to the volume. So that's what it means, right? So now if you want to find the volume of the smaller cone, we can compare it accordingly. So part B, volume of the smaller cone, okay, we call it W1, over volume of the larger cone will be the base of the smaller cone to the larger cone cube, right? So let's plug in the information we do know. The volume here is 378. Now 16 over 24 cube, let's figure out how much that is. 16 divided by 24. Then I cube it. Where is my cube button? Wait, how do I call the scientific calculator? I think it's this button. Scientific. Yes, to the power of 3 equals, right? Okay. My calculator, because I didn't bring my regular calculator home with me, I'm at home right now, so this calculator is not working very well. Never mind, we will do it manually. 16, if I divide by 8 will give me 2, 24 divided by 8 give me 3 cube, which gives us 8 over 27, right? So manual calculation. This is also manual calculation. So now we have V1 will be equals to 8 divided by 27 multiplied by 378, which gives us 112. And the units in this case, let's check the units, is cubic centimeter. Okay, that's all good, right? Part 3, they want us to calculate the mass of the larger cone. So since the mass is directly proportional to the volume, so part 3, the mass of mass 1 over mass 2, okay, we So if we now define mass 1 as the one that we're trying to find, which is the larger cone, it's going to be proportional to the volume. So the larger volume is 378 over 112, right? So M1 over 928 grams is, well, let's see if I can simplify this. 378 divided by 112. Now let's 378 divided by 378 divided by 4, 378 divided by 2. Okay, let's write down 189. I've got a feeling I can divide this by 9, right? Then 112 divided by 2 is 56. Okay, that works for now. Okay, so M1 will be equals to 189 divided by 56 times 928, which gives us 3132 grams. Okay, that looks good, right? The question did not insist that we write it in kilogram. If we are, it will be 3.132 kilogram. Okay, that'll be fine, right? Okay, let's check with what I did earlier. Yep, I got that right. Okay, so next one. Okay, now task 11. This time round, we have a right circular cone divided into two portions, M and L, and then there's a plane parallel. Okay, so we basically cut the cone into two halves. It's not exactly half, right? But the same height, right? So we do that. So what happened now is we want to find the ratio of the volume of M to L to M, right? So what happened is that L is not similar to M, obviously. M is a full stroke, right? However, L is actually similar to L and M combined together, right? So what we can do is the volume, okay, L, right? Volume of L over the volume of L and M together is actually K over 2K cubed, right? Which gives us 1 over 8. Therefore, volume of L over volume of M will be 1 over 7, right? So it's quite straightforward over here, actually. Right, moving on. Okay, find the area of triangle using ratio. We can do that. Okay, so again, these are the information we already know, right? Let's go. In the diagram, AD and BC straight line, sure, and it's given that CD is parallel to AB, and then you have the ratio. Okay, that's fine. So let's find the area of these two areas, ABE and triangle DCD. So that's that. So we're going to begin by looking at this ratio, right? This ratio is useful. Okay, so let me rewrite again, is CD, let's write properly, equals to 2/3 AB, right? So what this means is that CD over AB is actually equals to 2/3. Now we flip it around, it means that AB over CD is actually 3 over 2. Okay, so now what happened is down here I have my AB here and my CD, the length here, right? So this is the ratio of the sides, and these are similar, right? These are similar. So therefore, area triangle ABE over area triangle DCE is going to be equals to 3 over 2 squared, which is going to be equals to 9 over 4. All right. Okay. Moving on. Okay. Now what happened is down here we compare triangles with the same height. Over here we are comparing triangles with the similar, right? So similar, same height, different. When same height, based on what we know is half times base times height, since the height is the same, basically the ratio of the area will just be the ratio of the base. Okay, so that works. So this is an example of it. So in the diagram, OAB is a triangle. Okay, so OAB is triangle, and they have the same, and then we have triangle OCB and OAC, they all have the same height. Okay, so what we want to do is now we again start from what is given to us, right? So AC equals to 2 over 5 AB, right? So that means AC over AB is equals to 2 over 5. However, when we do a quick check, we are actually comparing AC with BC, right? So because of that, I'm going to continue my ratio. AC over this time round, instead of AB, I want to look at BC, right? So BC is actually AB subtract away AC, right? So it will be 2 over 3. So therefore, the ratio of area triangle OAC over area triangle OBC is going to be 2/3. And do I square it? No, I don't, right? Because this common height, this is not similar triangle. So you got to be careful when we are trying to solve this kind of question. So there we go. The solution is 2/3, right? Okay. Finally, we have task 14. Task 14, okay. I'm not completed for the faster class as well. So let's go through this together. So in the diagram, we have three triangles there. Very nice, right? And we want to show that triangle ABF and triangle ACD are similar. So this is fine, right? We can do this quite quickly. We know that angle BAF is equals to angle CAD, and because they are common, right? And then we know that triangle, let me see, ABF equals to angle ACD because of course, that it will be corresponding angle, right? Corresponding angles, and because BF is parallel to CD. There we go. So therefore, okay, triangle ABF is similar to triangle ACD, and the reason is AA similarity test. There we go. So part A is successful. Okay, let me change the color of my pen. Okay, part B, given the two ratio again. Do I have enough space here? Oh yeah, I do have enough space, right? So let's zoom out a little bit. So we're going to start with CD is equals to 1/3 CE, right? Let me label it part B. Okay, so let me CD over CE is 1/3. So, right? And that means that the ratio CD over DE is going to be 1/2. So I can mark it on my diagram to give some clarity. The ratio here is 1:2. Okay, so we have that for us, right? Then the other information we have is this triangle BC equals to half of AB, right? So BC over AB equals to 1/2, right? So BC over AB is 1/2. Again, we can just do a quick mark on the diagram. This is 1:2, so that's the ratio. So with this ratio in place, we can now try to answer the question, right? So we want to find, first of all, okay, area of ABF to ACD, right? ACD. So area of triangle ABF over area triangle ACD is going to be 1/2. They are similar triangle, so square, which gives us 1/4, right? Oops. Rewind. let's do it properly. Sorry, this one will be 2 units to 3 units, right? And they are similar, so I'll square it. This is 4/9. Okay, so we have that. Then for part 2, we have a triangle ABF to ADE. So now these two don't have direct comparison, but what we do know is we know that if this portion here is like 4 units, right, this portion here will be 5 units, so that the total is 9 units. And then based on the comparison, right, the triangle area of triangle ACD, right? ACD over area of triangle ADE is equals to 1 over 2, same height, which is 9 over 18, right? So therefore, area of triangle ABF over area of triangle ADE will be, replace the 9 with 4, so 4 over 18, which gives us 2 over 9. And there we have it. This is a higher order, slightly more challenging, but if you actually understood and you can do this on your own, congratulations. Right? So I hope you have a good understanding of this chapter. If not, watch the video a couple of times until you get it, and then try it out on your own. Right? All the best. Have a nice day.